Hello, everyone. Here we are with a quick tutorial of some tips and tricks to use Modelsim to help debug your four-function calculator lab. Not only will this be helpful for debugging the lab, but it's also critical in developing the intuitions we want you guys to have for debugging Verilog modules in the future, maybe even in your future careers. So here we have the boothmul file that we give you guys. There's a error that we threw in there somewhere, and that's what we're going to try to track down right now. And here we have the test bench also that we give you. So something I like to do just to make everything easier to read in my test benches, I always like to split up and segment the tests, and you can usually use the delays to know when the next segment's about to start. So here we can see that our first test is going to be 7 times -8. And then our second test is going to be 7 times -6. So hopefully at some point in between there, we see the result of 7 times -8, which should be -56. So here I already have it loaded into Modelsim. I'm just going to load in the signals that we see from the test bench right now. Now, before I simulate this, something I like to point out, it may be hard to debug if you don't know what signals you're working with, just looking at the waves right here. In Modelsim, it likes to, before the signal name, it likes to include the module it's being called from. So here you see boothmul test bench. Something I like to do is if you right-click on it, click on Properties, you'll see this window pop up right here, and then you see the full signal name. Just to shorten that, I would like to change it to remove the module it's being called from. So here we're just going to do clock. We're going to apply it, and you see that's shorter. I like to have as much wave view as possible, which is why I like to do that. But if you'd like, you can also expand this window right here to see all the names. Okay, so I'm going to go ahead and simulate it. And let's see. Okay, so we see our test right here, our multiplier and our multiplicand, 7 times -8. And then we see the multiplicand switching to -6. So we have 7 times -6. Our result is stored in P, but it looks like it never changes from 0 this whole time. So I think we have an issue there. So something I like to do is try to track that down and work backwards. So what we're going to do is we're going to come back over here to Quartus. We see P goes into this last port for boothmul. So we're going to go up to boothmul, check it out. Here we have P again, so we use the same name since we're using implicit instantiation. I'm going to scroll back down and try to find where P is assigned. I remember that it's all the way down here at the bottom. So we have P is being assigned. It checks this all done control bit. And either it's assigned PM through WW through 1 or 0 if the all done control bit's not set. So we want to check all the dependencies here. Since 0 is hard-coded, we don't have to check that. But what I want to do is check all done in PM WW through 1. We can just check the whole PM register. So we're going to go back to Modelsim. A very useful tip, if you haven't figured this out already, is if you look over here on the left, what you can do is you can see the modules being called from the test bench and all of those subsequent submodules. So again, back to Quartus in the test bench. We always like you to create instance names for the modules being called. So here, boothmul is called with the instance name BM. And you can see that right here. So the instance BM is right here, and you can see the design unit is boothmul. And now that I've highlighted that, you can see all the signals within BM, within the boothmul, instead of the ones that we saw from the top level test bench, right? And you can keep going down the line. So, in boothmul, we call add sub. So right here, you see add sub 1, the design unit add sub. See all the signals from inside add sub. We could expand that, go even further. This is within the for loop that you'll see in the add sub module. And then we can see the full adder signals. So we click on full adder and we see all that. So if you're trying to track down a bug, maybe that has to do with improper addition or subtraction, this might be a useful tip for you. But we think that our issue is just going to be with that PM register or that all done control bit. So let's go back up to BM. We're going to look for all done, which I see the signal right there. We're we're going to look for our PM register, which is right here. Something that's usually useful as well is checking out your state registers, just making sure you're going through the right sequence of states that you have designed. I'm going to throw those in there just for reference. And other things that might be relevant to that. So in this case, counter might be useful. And if you find you're going through the right sequence of states, you might want to check out your control bits like we're doing right now with all done. Okay, so I'm going to restart this. We have all the signals we want. And I'm going to run it. Okay. So again, we're looking at PM. We can expand it. It looks like PM is getting some correct values. And what we can do is see how we have this cursor here. As we scroll the cursor, you can see the values of your signals at the instance that the cursor is over. So if I go right where I want the value to be, you could see that PM equals -112, but if you remember, we're doing WW through 1, so you actually have to divide by 2. You imagine it's all shifted over 1, so that would be -56, which is exactly what we want. So we know that PM has the right value at the right time. It looks like this all done bit is never getting set. So we have an issue with our all done bit. Now we know if we look back at our states from Boothmall, we'll want all done to be set when we're in the state done right here, right? We try to use that naming convention just to make it a little bit easier to follow. And if we look over here, the all done control bit, it's just been hard-coded 0. So we think that might be our issue right now. So I'm going to go ahead and fix that. Change it to check when state equals done. Save that. Now we're going to recompile. You want to simulate again from the library folder. Okay, let's get all of these signals back in there. And then just to make sure that what we were checking out before still works, we're going to get all the same signals back over, all done, PM, and then our state. And let's go ahead and run it. You can click on this blue magnifying glass to zoom full, see the whole wave. And if you look closely, it looks like our result register P is actually a little different. Let's see if we can zoom in here, and there you go. -56, the all done bit, is getting set right when that -56 loads. So there we go. We fixed an issue using Modelsim. Hopefully this gave you guys some useful tips that you haven't known already to help you with debugging the 4-function calculator lab. Good luck.